All right, we're going to start going over the video, the test from 2015, the first Geometry Common Core test that was given. So we're going to go over that test. We'll go through the first 5 in this video. All right, so let's look at number 1. All right, it says, which object is formed when right triangle RST, so that's RST, is rotated around leg RS. Leg RS, remember, a right triangle, so you're going to want to write this down, a right triangle. It always has 2 legs and a hypotenuse. All right, so I want you to write that down. Not necessarily, you don't necessarily have to know that for this problem, but it is something I want you to write down and remember. All right, so it says which object is formed when it's rotated around RS. Well, you have to imagine, and if you've been in class consistently, we have been doing problems like this. But if you imagine this rotating, remember it's rotating around this. So if you can imagine it, this point that I'm putting here, R, is going to stay there. The T is going to be, if I rotate it around once, T would be over here, and then it would go around, and go around. If you just keep rotating it, well, what's going to happen? You're going to end up with a cone. Hopefully that was easy for you because we have been going over problems such as that. All right, so number 1 is 4. All right, let's look at number 2. It says the vertices of triangle JKL have coordinates of J is 5, 1, K is -2, -3, L is -4, 1, under which transformation is the image triangle J prime, K prime, L prime not congruent to the original triangle or the pre-image of triangle JKL. Well, if you remember back to transformations, we talked about a couple different types of transformations. We talked about, so let's go back to our rigid motion transformations. So rigid motion transformations. And what does that mean? That means that the size and shape, size and shape are preserved, and the distance between the points is preserved. All right, so rigid motion transformations were translations. That's where a shape is moved. Translations, rotations, reflections, those are 3 I remember off the top of my head. If you remember another one, let me know. But the main thing to remember is that what is not a rigid motion transformation? Not, which means size and shape is not preserved, or distance is not preserved. Distance between each point is not preserved, or it doesn't stay the same. So non-rigid, wow, spelled rigid wrong. Let's try that again. All right, non-rigid motion transformation. And the one we talked about that should be fresh in your head, hopefully, are dilations. Dilations are not necessarily going to be a rigid motion transformation. Now, if you do a dilation of 1, that's the one case to where it will remain, or distance will be preserved. But if you look at number 4, it says a dilation with a scale factor of 2. And so, remember, it says not congruent. Be careful, which which transformation is going to make an image that's not congruent to the pre-image is going to be 4. If you look at the first 3, distance is preserved. So the size and shape is preserved. Remember, reflections, you're just folding on a line, maybe the x-axis, the y-axis, or y equals x or something like that. But the size and shape don't change. And the distance between the points does not change, right? So that is number 2. Incidentally, you should be trying these beforehand, just to check to see your answers, checking to see if they're right. So I'm going to do number 3 in just a second. Okay, looking at number 3, it says the center of circle Q has coordinates 3, -2. If circle Q passes through point R, which is 7, 1, what is the length of the diameter? All right, so I want you to write down this definition of a circle, just for a reminder, just to refresh your memory. Then you can draw a little picture here. Okay, I want to draw 2 pictures. We have a center, just to make sure you remember that this is R. If I draw another circle, that this is D, or the diameter. That's important in this problem, because you can do a lot of work in this problem if you don't remember. It's looking for the diameter, not the radius. Not the radius. So be careful. Don't do a lot of work and then make a simple mistake. But I'm going to take you to something that a lot of students do not utilize, and you should have the test that I gave you, which means you have graph paper in the back of your test. All right? I'm going to go ahead and go to that graph paper. All right, this is what you have. You actually have 2 sheets of this, which is a good thing. What you want to do on a question like this, first of all, obviously you're not given X and Y axes, but you can make your own. So I'm going to go ahead and do that. So I'm going to make my marker. Okay, so what I'm going to do is make some axes. I'm only going to use the corner of the paper. I'm not going to use too much. I guess you could always erase if you have a pencil. Nowadays they make you use a pen. So hopefully you have a pencil with you. So if you use the graph paper, use a pencil so you can erase it. But utilize your space. So let's go back to the problem now. It says the center of circle Q has coordinates 3, -2. So based on what I drew, I would have my point here, 3, -2. You need to be drawing this also. If you want credit or the extra credit points, you need to be doing this on your graph paper. All right, now it says the circle is going through, it passes through 7, 1. That means the edge or the outside of the circle is going through 7, 1. So now I'm going to go 1, 2, 3, 4, 5, 6, 7. So this is my point 7, 1. Okay, now remember the definition of a circle. We'll pick up a different marker now. It's the set of all points equidistant from a fixed point. So if I have my center point here, if you guys were in class at the beginning of the year, I had you do an exercise to where I had you put a center point on your paper, and then I had you to draw 20 points that are all 3 centimeters away from that point. I believe it was something like that. So, and what people discovered is when they started doing that, it came up something like this. Okay, so now looking here, if we have a circle, we know that this is actually going to look, something like this. It really doesn't matter exactly, but we do know it's going to look something like that. So what you have, that's actually a pretty bad drawing, by the way, but, anyway, what you're going to have is this right here is going to be your radius. Now, could we find that distance? Well, we can find that distance by the fact that we know we can create a right triangle. So you notice what I have right here. Hopefully you're watching. I have a right triangle. But you might say, well, what are the lengths? Well, that's pretty easy. Our length down here is just going to be 4. That's our x value because it's over 4 units, right? And it's up, so our y is actually going up 3 units. So we actually just have a triangle, a right triangle, because this is going to be a right angle, with legs 3 and 4, and the hypotenuse represents the radius. So I want you to write that down. The hypotenuse represents the radius of a circle, of the circle. All right, so now if you recognize that, over here is just going to be x, or whatever you want to call it. If you want to call it c, and I know you guys are used to a squared plus b squared equals c squared, you know, whatever it is, whatever you want to call it, if we find that, we basically now just have a triangle like this, 3, 4, and x. And if you remember our special triangles we've talked about over and over and over again, you'll probably look at it and say, okay, that's 5. But if you don't remember that, just do 3 squared plus 4 squared is equal to x squared. We end up with 9 plus 16 is equal to x squared. And coming up here, we have 25 is equal to x squared. Now, let's look back at the answers they give you. They're trying to be tricky because they have this 25 here. They have this 50 here. Okay, so if you make the mistake and say, oh, 25, that's my radius, or that's my side of the triangle. Well, you should remember that that couldn't even make a triangle because you can't have sides 3, 4, 25. Remember from our inequality theorem, triangle inequality theorem, you can't even have that. And so hopefully you don't make that mistake. Our x is going to equal 5 because you have to take the square root, remember? So x is equal to 5. Now again, tricky. They give you 5, but remember they're not looking or asking you for the radius, they're asking for the diameter. So your answer is going to be 10. Okay, not much to talk about on number 4, but let's just make sure, and I want you to label this on your test. This is our pre-image. And how do I know that? Well, it doesn't have the little prime symbols, these little symbols here. And we know that our first image, this is our first image. And I can tell that because it only has one of the little tick marks or apostrophes, I guess you'd call it. And this is our second or final image. All right, so which one of these sequences of transformations will map this figure onto this figure? Also, it says figure 1 onto 2 and 3. So it's not always going to say that, but it's asking you what's going to map 1 onto 2 and then 2 onto 3. All right, so looking here, reflection. We talked about a reflection. Remember, if it was a reflection on the x-axis, all your points would be, D would be down here. So that's not a reflection as we've talked about it. So that can eliminate number 1. A rotation, well, remember, a rotation would have this doing something, everything would be, your direction is going to change of where the points are, because so you're going to have something like this, right? And the points don't look like they're going to match up, and so that's not going to work. All right, let's see, a translation followed by a reflection. Well, this could be a translation because, remember, a translation is just moving, so really you could say it's moving over and then up, all right, which makes sense, but the reflection part does not make sense. This 2 is not, the way 2 is not going to be reflected on the 3. The only one that makes sense is a translation followed by a rotation. All right, translation followed by a rotation. All right, look at number 5. It says, as shown in the diagram below, the angle of elevation from a point on the ground to the top of the tree is 34 degrees. All right, they give you that right here. That's your angle. Okay, now if the point is 20 feet from the base of the tree, what is the height of the tree to the nearest tenth of a foot? All right, so if the point is 20 feet from the base means bottom. What are they talking about? Are they talking about X or are they talking about Y? Which one of those? Hopefully you recognize they're talking about what I labeled X. So I'll go ahead and erase those. I'll put this as 20. They actually give you that information, but they don't put in the diagram. So you have to put that on the diagram for yourself. Now you also have to figure out what are we looking for. It says, what is the height of the tree? So first thing you need to remember is we're looking for a side, not an angle. They can have you look for an angle, but we're looking for a side. So I'm going to write this down. We are looking for a side. So we are going to use regular trig functions and not the inverse. Remember, if you're looking for an angle, that's when you have to do second sine. Go to the calculator. That's when you have to do second sine and things like that. I'm kind of getting ahead of myself. Let's go do the problem. All right, so we're looking. What are we looking for? We're looking for the height of the tree. That is not what I'm about to dot. That is not the height of the tree. The height of the tree is this. I'm going to label that as X. Now, another thing I want you to write down. Soa, Toa, some on horse, caught another horse, taking oats away. I want you to write that down. All right, which trig function is going to be applicable here? Well, we have, based on the angle. Remember, you're always basing it on our given angle, our reference angle. They gave us the 34. What do we have based on that? This is what you always want to think about. What do you have and what are you looking for? Well, we have this side of 20, which based on our degree of 34, that is our adjacent side. And we're looking for the opposite side. All right, so we have the adjacent side, we're looking for the opposite side. We don't know the hypotenuse, we're not looking for the hypotenuse, so that is not going to factor in. If you look at these three trig functions, the only one that does not involve the hypotenuse is our tangent function. So remember, this is tangent of an angle is equal to the opposite side, which is X, or whatever you want to call it, you can call it whatever you want, over the adjacent side, which is 20. All right, so now we can just, if you want to put this over 1, that's fine. You can cross multiply, and you end up with 20 tangent 34 is equal to X. So I'm going to go into my calculator, and I'm going to do 20 tangent 34, and I get 13.4. Now, one thing you want to make sure and do, and I should have changed it because I wanted to make a point of how you could make a mistake. If you're in the wrong mode, I'm in degree mode, which is what you want for this particular problem. If I had been in radian mode, and when you get your calculators on the test, I'm pretty sure they're going to be in radian mode. You're going to have to change it. If I was in that mode and I did the same thing, I'm going to come back down and do 20 tangent 34, your answer is much different. Much different, obviously. So you want to make sure and be careful. Be careful that you're in degree mode. I don't think anything that you do, you'll need to be in radian mode. Almost positive about that. So just switch it to degree mode. Don't worry about radian mode until you get to algebra 2. All right, so our answer now is number, let's go back and see, let me look at my number here. 13.5. There we go. So that's the answer. All right, so make sure you have the things written down that that I asked you to write down. And I'm going to go over the next 5 at some point. But this is a good place to get started, and hopefully you got something out of it.